Okay, let's go ahead and finish up these notes, and then we're going to go ahead and then look at homework 2 and 3, go over just a couple of practice problems, and then I'll give you the answers. Again, it's just for practice. It's not for a grade. You actually have 3 grades every single week in this class. First grade is going to be do the reading assignment and answer the questions from the CK12. Those questions are going to be on Blackboard. You're going to download them, print them, whatever it is, answer the questions, take a picture, upload it, or else upload the document that you saved. Every question above the amount of questions that are required will count as 1 point onto the test. So that's your first assignment. Your second assignment is going to go to the CK12 website. And after you do the readings, then there's going to be a quiz at the end. Then the third assignment is going to be your test. It's only going to be 10 questions every week. The test will not be available until Thursday afternoon. So about 2 o'clock, it's going to be open. And then after that, it will stay open until Sunday. You do not have to wait till Sunday to take the test. But if you want to, the test will be available till Sunday at 11:59. Okay, so let's go ahead and go back over here. We have the first type, which is what we call a synthesis. It's what we call a redox. And the reason why we call it a redox is because a redox occurs whenever we have a single element that's involved, whether it's on the reactant side or whether it's on the product side. Okay, so here I've got some single elements. I can actually have 2, I can have 3, I can have 4, doesn't matter. But what happens is they combine together and form one new product. So for an example, A plus B equals AB. Here is my reaction. You go back and you make sure that it's always going to be balanced all the way down. Balance, balance, balance. That's perfect. Let's keep going. We have second type, which is what we call decomposition, which is the opposite of synthesis. If synthesis means to bring it together, decomposition is the opposite, which means break it apart. A single reaction, so it's one thing that's broken apart into 2 or more. So let's just say I have the black elements or atoms, I have the white ones, and then if I had red ones over here, that's all into one section, I would have black atoms, white atoms, and red atoms separated. Okay, so I have AB. It could be A, B, and C that yield A plus B or A plus B plus C. They gave us another example. Mercury 2, that means the +2 oxidation, oxide. Oxygen's a -2. Decompositions or decomposes, which is the yield arrow, when heated. And when it's decomposed, that means that this is breaking apart into mercury and oxygen. So Hg plus O2. I know this is going to be 2. The reason why it's 2, because it's going to be a diatomic, right? This one and this one are going to be a 2 and a 2, but even though it's a 2 and 2, they reduce and it's HgO. But now let's come and balance it. There's 2 over here, there's 2 Hg's, and there's 2 O's. It's actually perfectly balanced. I would go ahead and put a 2 in front of this also, so you can see that. Most people don't even put a 2 here. And the reason why they don't put a 2 is because they know that there's a 2 here and a 2 here that's invisible because it was reduced to a 1 and a 1. Okay? But sometimes people like to put a 2 in front of it just so that way you can physically show it. Either way. Next one, the third type, is what we call combustion. Combustion is just like it sounds, with fire. And if you have fire, you have to have oxygen, right, for that fire to be able to burn. So it's any substance combining with oxygen. All products will have, it says here, oxygen in them. I'm sorry. It's going to have it in it, and it's going to have it in the reactant side also. Energy is usually released in the form of light and heat. So AB plus O2 yields energy plus AO plus BO, because this is going to break apart and this is going to go here and that's going to go here. Let's go ahead and look at an example of what a combustion looks like. 2H2 plus O2 yields 2H2O plus energy. H's. 2 times 2 is 4. H's. 2 times 2 is 4. Check. Oxygen. 1 times 2 is 2. Oxygen. 2 times 1 is 2. Check. It is balanced. Let's go ahead and keep going to the next reaction type. The next one is also a redox, and it's going to be, what was the last one? Combustion. Oh, it looks like they're still looking at combustion over here still. So it's still a combustion. It says here combustion of carbons and hydrogen compounds. Reactions commonly involving what we call hydrocarbons. So it's an H and a C. That is a hydrocarbon. Hydrocarbons are also always produce carbon dioxide and water. So here I went ahead and balanced it. Now there's a little trick. If it gets to the point where, for an example, this was actually, I had to make it a 7.5 here. And this was for me to balance it. And when you get some weird number where you have to make it a 7.5 to balance this, if you multiply everything by 2 all the way across, 7.5 times 2 equals 15. 2 times 1 is 2, and you just keep on, and you put a 2, multiply this coefficient by 2 all the way across, and then yes, you end up balancing it out at the end. So there's only a couple of tricky ones. Let me go back and double look and make sure when it comes to the test that we don't have any of those at that difficulty. Okay, let's keep going. Fourth one is a single replacement. Atoms of one element replace the atoms of another element in a compound. Okay, so for an example, I have A, single elements, plus B, C, which are combined. What happens here is that A is going to knock B out of the way, and B comes over here by himself. So now I have AC plus B. Here's a couple of examples. The C scoots in. He comes over here into the AG spot, kicks AG out by himself, a single replacement. Here, F knocks out the BR. Why is F not going to knock out the Na? Because Na, sodium, is a metal. Non-metals are only going to knock out non-metals. Metals, Cu, is only going to knock out metals. Okay? A non-metal cannot take the place of a metal. Let's keep going. Aluminum metal reacts with, so Al, with copper 2 chloride, CuCl2. Since that's aluminum by itself, he is going to replace the Cu or the copper. He is not going to replace the Cl. Metals replace metals, non-metals replace non-metals. And so go ahead and fill in the notes if you need to, pause it, so that way you can see the examples of the reactions that are occurring. The next one here is not a redox. It is what we call a double replacement. They are not redox. Why is it not a redox? Because it does not have a single element on the product or on the reactant. For an example, A plus B equals C plus D. Plus C plus D equal AD plus CB. Now we need to look at it. I have a metal, non-metal. Remember, when we are naming, we always name the metal before the non-metal. Plus a metal and a non-metal. When they are going to change and take place, when that takes place, the metal is going to change with the metal. The non-metal changes with the non-metal. So on this case, we're going to have over here A and D, metal and non-metal, plus C and B, metal and non-metal. Okay? That's what we call double replacement. It is not a redox. Now, there's two types of double replacements. Okay? Acid-base, which is a double replacement, and a precipitant, which is a double replacement. Acid-base, it has the word acid in it, so that means that it's going to have to start with an H, right? Hydrogens. As a reactant, and on the product side, how do I know that it's going to be acid? It always ends up with an H2O, water, and a salt. A precipitant. A double replacement occurs where one product is actually soluble salt and the other product becomes an insoluble salt, meaning that a precipitant or a solid is actually formed. Okay, using the solubility chart though, you determine if the products are going to be soluble or insoluble, meaning when you use the solubility chart from your notes that you're going to need on the test and quiz, then you're able to tell, is it going to be soluble, which is a solid, or insoluble, which is going to be a liquid, right? So let's look at it. Here are two precipitant reactions, 1 and 2. 3 and 4 are acid bases. How do I know? Because they're going to have H. One of them are going to, look, there's an H. Here's an H. Okay, I'm sorry, here's the H. Here's the H. Here we go, precipitant. On a precipitant over here, I have NaS plus CdNO. NO3 is a polyatomic, which is a nonmetal. S is a nonmetal. Na, metal. Cd, metal. So this one's going to form with this polyatomic. The Cd is going to be the metal that is going to be with the nonmetal sulfur. So here we go. CD, S plus Na, metal first, NO3. Well, how do I look right here? I wrote this as a solid, and this is going to be a liquid and aqueous. How do I know that this is a solid? Well, I know first thing is that this is a double replacement. Then I need to decide, is it an acid base or a precipitant? It's not an acid base because it doesn't start with a hydrogen over here on the reactant side, so it must be a precipitant. When I have a precipitant, that means that one of those products are going to be a solid, one's going to be a liquid. Well, how do I know the CdS is a solid? Why isn't the NaNO3? Well, now let's go to your solubility chart in your notes. Soluble, insoluble. This right here means that these are going to be solids. The word soluble means that it's dissolved. They're going to be liquids. Okay, this is actually on your formula chart that you've been using all school year also. Now, when I look at this, remember, it was actually, what was it? It was CD. Here it is, CDS NaNO3. So let me write that over here. CDS or NaNO3. Remember, that's a polyatomic. Let's look. Liquid. Oh, I'm going to look at the first one. CDS. CDS, 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 CD or S, CD or S, CD. Nope. That's an SO4. That's not S. It's not just an S. Let's look over here. CD or an S. CD or an S. Look, there's an S here. That means that it's going to be a solid. Okay. Except, here are the exceptions. Except if it's compounds with NH, no. It's combined with CD. Is it combined with Ca? No. It's combined with Sr? No. Or Ba? No. So then that means that yes, it's going to be the solid. This sulfur, when it's combined with anything, will end up as a solid as long as it's not one of the exceptions to the rules. Okay? So all of them have exceptions to the rules. Okay? What was the other one? The other one was NaNO3. Do we see an Na? No, but I have an NO3. NO3 is going to be a liquid. Is there any exceptions? There's no exceptions. It will always be a liquid. So going back to your notes, that's why there's an S here for solid and an Q for aqueous. Let's look. FeSHCl. Oh, that's an HCl. But look over here. we do not produce H2O. And since we do not produce H2O, then this is not going to be an acid, not an acid base. Alrighty, so let's look at this. The Fe will combine with the Cl, and the H will combine, even though, yes, it is a nonmetal, he is acting like a metal, right? That's why he has a +1 charge, so he is written first. H2S. Why? Because the S has a -2 charge. Crisscross those, the 2 comes down here. I need to decide which one is going to be the solid. Well, okay, you already know this is a solid, but let's go double check. H2S. Let's go back over here. S, solid. The exceptions. If they have H as an exception, then it won't be a solid. But look, there is no H's. So then in that case, then it's going to be a solid. What's my other option or my other thing? FeCl. That means that Fe or Cl has to be up here. Here it is, Cl. Cl, when it's combined with something, will be a liquid, except for Ag, nope. Pb, no. Hg, no. So that means that this is going to be the liquid or aqueous, and that's going to be the solid. Let's keep going. We've got calcium hydroxide, CaCO, CH, to the 2 comes down, with HCl. Yields CaCl2 plus HOH. And we do not write it as HOH. No, we write it as H2O. Because H2O is in the product side. This is an acid base. Let's look at the next one. HCl plus NaOH. The H is going to come over here and swap with the Na, and it's going to combine with the OH. We do not write it as HOH. We write it as H2O. The Na is going to combine with the Cl. NaCl. Okay, so acid-base reaction. Again, it is a double replacement, and that is not a redox. In your notes, here's what you wrote down. Types of reaction. If there's a single element that occurs in the reactant or product side, then it's going to be what we call a redox. If there's 2 or more elements, then they're not a redox. So over here, a redox, there's 4 different types: synthesis, decomposition, single replacement, and combustion. Not a redox, there's 2 different types. There's acid-base, and there's double replacement, which can be a precipitant. They're not always a precipitant, but they can be. So I just call it a redox, not redox. Okay. Other than that, our notes are done. Let's take a couple of looks at some of the homework examples, and then that is it. The rest is, again, for you to go and do the readings and practice all of that. Homework. Turn it to homework number 2. Again, I just want to practice only a couple of them with you. I'm going to give you the answers after that. Alrighty. So let's look at homework number 2. First one over here. I've got H2O2, which is going to yield H2O plus O2. Well, first thing is, I see a single element over here, so I know it's going to be a redox. And then I see that I only have one thing on the reactant side, and it breaks apart, so that means that this is going to be a decomposition. Okay, let's look at the next one. I've got 1 plus 1 equals one new thing on the product side. We know that there's one single element here, so that means that it's going to be a redox, and it combines into one new thing. It's called a synthesis. Next one, I have one thing over here. It breaks apart into 2 things, and look at that. H2 and O2 are both diatomics, but they're single elements. So again, we call that a redox and we call it decomposition. Okay. Down here, I have, look at this, a single element. So that's a redox. But I have two over here and one over here. What happens is that this one is going to come over here and replace, and this oxygen actually breaks apart into two. So CO, HO. But look, I end up with oxygen on this side, H2O on this side. We call this a combustion. I'm just naming them types just by looking at them. I still have to go back and balance them. Next one, I have a single element, and I have a single element redox again. I have this one is going to, this metal is going to take over the Ag. A single one is going to replace it. So that's a single replacement. Uh-oh, O2. What is that? Diatomic, considered to be a single element redox. What happens is I have O2 on this side, I have H2O on this side. We call it combustion. Look at this, zinc and H2, single elements, redox. What type? The zinc is going to knock out the H. Even though H is a non-metal, he acts like a metal. He has a plus charge. And so the zinc takes over his spot. That's going to be a single replacement. Okay? So that's first thing. Now, the next thing is to go back and, bless you, to go back and balance this. Let's do this one. I have C's, I have O's. 1 times 1 is 1, 1 times 1 is 1, 1 times 2 is 2, so 2 plus 1 equals 3. Let's come over here. 1 times 1 is 1, 1 times 2 is 2. I'm not balanced, so I need to, let's see, more oxygens over here. First thing is there's a 1. I like to just go up one number at a time. So let's make it a 2. If it's a 2, 2 times 1 is 2. 2 times 2 is 4. Okay. Now my carbons are off on this side. So let's change it one number to a 2. 2 times 1 is 2. 2 times 1 is 2. Plus 1 times 2 is 2, so 2 plus 2 equals 4. 2 and 2, check. 4 and 4, check. I'm balanced, plug in a 1, and I'm done. Let's look over here. Let's fill in the blanks. I have H, G, and O, and they are going to decompose and break apart into Hg plus O. Let's look at this. K plus S are going to combine and be a synthesis. And I'm going to have K2S. How do I know it's K2S? Potassium has a +1 charge. Sulfur has a -2 charge. Crisscross those suckers. The 2 comes down here, K2S. Next one, lithium plus something is going to form lithium and iodine. So this has to be an I. Alrighty, not too bad, is it? You need to name those over here. Then let's keep practicing over here. Let's come over here. I'm going to do this one. C's, H's, and O's. 1 times 3 is 3. 1 times 8 is 8. 1 times 2 is 2. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is 2. 1 times 1 is 1. So plus 1 equals 3. I'm not balanced. I need a lot more H's. So 2 times what equals H? 2 times what equals 8? Well, what if I put 2 times 4? Oops. So now let's recount. H's. 4 times 2 is 8. But oxygens. 4 times 1 is 4. Plus 1 times 2 is 2, so 4 plus 2 equals 6. I'm not balanced. I need some more C's over here. 3. 3 times 1 is 3. But wait a minute. Look at it. It affects the O's. So let's recount the O's again. 3 times 2 is 6. And 4 times 1 is 4. So in this case, I end up with 10 O's. This side, I need to have 10 O's over here. So there's a 2 here. 2 times what is 10? 5. 5 times 2 is 10. 3 and 3, check. 8 and 8, check. 10 and 10, check. I am balanced. What do? I plug in a 1 where I'm left over. Okay. I'm going to go ahead and you're more than welcome to pause it. I'm going to show you the answers really quick and then turn the page. Okay. Hopefully you paused it, rewind it, whatever you need to do. I need to turn the page so we can keep going. The next one over here, this one's going to take this place. This one's going to take this place, and AG will take his place. All of them are going to be single replacement. Since they're all single replacements, then they're all going to be redox reaction. Single element, single element, single element. Alrighty. What happens here is that the Cl is going to be by himself. I'm going to end up with the NaBr. The Na has a +1 charge. The Br has a -1 charge. Crisscross them. I don't have to put anything down here. Please do not forget to find the charge for every single time. So that way you can write the little number at the bottom. Crisscross it and write it down. H ends up by himself. Mg is going to combine with SO4, which is a polyatomic. Mg has a +2 charge. SO4 has a -2 charge. Crisscross those. A 2 and a 2, we need to reduce and leave it alone as a 1 and a 1. The next one, I need to have the Ag is going to replace the H. So AgCl plus H by himself. Wait a minute. H by himself, he's a diatomic, so he's an H2. Don't forget that. So there's a few things that you need to remember. You need to remember to reduce. You need to remember to go ahead and have your charges and crisscross them. And then you need to remember your 7 diatomics that I showed you how to use the periodic table with. If you want to, you can pause it. I'm going to give you all the answers, and then we're going to turn the page. Oops, that should be it too. And there's the answers. Okay. Last one is homework number 3. Homework 3 looks like this. Multiple choice, or matching, I'm sorry. And then there's a couple more over here. Let me find homework 3 so I can show you homework number 3. And this is it. This is the end of the video. If you want to pause it, go ahead and pause it. But here are the actual answers. There may not be all the answers. I think I'm missing a few of them. But again, it's there for you to help you. I would practice this on my own first and then go back and double check the answers. Okay, we are done.